All right, welcome back to the next video in our distance learning series for pre-calculus. This week we're going to get into a new topic after a couple of recent conic sections. We're talking about vectors. It's something that if you've already had physics or in physics, you probably know what a vector is. But we're going to get into some different properties and make sure everything's good with that. As always, a good idea to have a piece of paper and something to write with as we go along. There'll be a few things for you to jot down that'll help you on the homework and the assignment as you kind of go forward with that. My initial intention was to play you this clip from Despicable Me, but I'm afraid that when I upload to YouTube, it's going to get blocked. So I will put the link for this little 1-minute clip. It's one of my favorite clips math-wise. But, you know, if you remember that scene from Despicable Me, Vector introduces himself because he wants to commit crime with both a magnitude and a direction. And that quote that he says is actually completely valid for what a vector is. It's a mathematical quantity represented by an arrow with both magnitude and direction. So if you remember that, you're going to be ahead of the game. Okay, so as we get into this, let's get into just some basics of what a vector is, notation, and stuff like that. So first of all, you've known this since you were back in probably elementary school, that if you see parentheses 6,3, that's just a point that would be over there, right? Well, for vectors, we notate that with little pointy brackets instead of parentheses. So it still means the same thing. That's still going to be the end point. What we call 6,3 in those pointy brackets, we call that component form or standard form. And we call that in the standard position. And what does that mean? Well, that means that vector starts at the origin, always at the origin if it's in that component form. And then it ends at that point x, y. Okay, so we call x that horizontal component, that would be 6 in this case. And we would call y the vertical component, or 3 in this case. Okay, so it's just that notation and kind of understanding the difference between the point and the actual vector to that endpoint. So here's a second vector, just another quick example. So if you have the vector 2, -5, think to yourself what quadrant that would be in. Well, again, it's going to start at the origin and go down to that point, which in this case would be in quadrant 4. Okay, so again, start from the origin all the time, down to point 2, -5, and that's going to be a vector with the horizontal component and the vertical component. Now let's talk about the two things that Vector said that he's going to commit crime with, one of them being a magnitude. Okay, so first of all, let's name our vector. A lot of times, again, a little bit of notation. We usually notate a vector as a bold letter. So anytime you see a bold letter, that's what you're talking about. So I'm going to call this vector 6,3 vector P. So magnitude, what does magnitude mean? Now, it's just another name for length. Okay, and if you look at that picture, go back into your mathematical toolbox. What do you have at your disposal that would allow you to find the length of that arrow? Well, you're probably saying to yourself, wouldn't it be the Pythagorean theorem? And you're absolutely correct. So all you got to do to find the magnitude is square both the components, so the 6 and the 3 in this case, add them together and take the square root. So in this case, it would be 6 squared, which would be 36, 3 squared, which is 9, add those together, you got root 45. Now you can put that in a calculator also and find the decimal. I don't really care one way or the other. I'm just going to leave it as a radical. Okay. Now the one thing I want to do here is, as far as notation, those double bars around the vector, that just means magnitude. Okay, that's all that means. Don't freak out about it. If you see the double bars, that's just going to mean you're going to find magnitude. If you need to jot that down in your paper, that little formula for the Pythagorean theorem, please do that. So let's do the second vector we had, that 2, -5. Let's find the magnitude there. So again, you know it's going to be the Pythagorean theorem, square root of the sum of the squares. So 2 squared, -5 squared, add them up, take the square root. Now guys, make sure and watch your signs. It's always going to be a positive number. So in this case, it would be root 29. How about the second thing? So that's how you find magnitude. How about the direction? So let's go back to my first vector p, that's 6, 3. Well, if we want to find the direction, and what do I mean by direction? First of all, it's going to be that angle from the positive x-axis, okay? So from here to here in this case, it's always going to go in that positive direction, okay? To find that, you have to go back, you remember your SOHCAHTOA. So if I want to find this angle right here, which trig function would I use given that I have the horizontal side of 6 and the vertical side is 3? Now, for this, and this works for any vector, you're always going to use the tangent function, okay? And in fact, it's going to be the inverse tangent because you're finding the actual angle, okay? So again, if you need to jot that down in your paper, that's the second formula that you need for the direction. So tan inverse of y over x, always y over x. Now, whatever you're using, whether it's Desmos or if you have an actual calculator or whatever, make sure that you're in degrees. Okay, so you pop that in your calculator, again, y over x, 26.6 degrees, and that's in quadrant 1, so that's all we got to do. That's all we got to do. That's going to be your final answer. How about my second vector, my vector r that I had a second ago, that 2, -5? Well, if I want to find the direction, again, it's the same thing. Okay, so inverse tangent y over x, make sure you're in degrees. Pop that in the calculator. So the calculator in this case gives you -68.2 degrees. And that's that angle kind of going backwards down from the x-axis. Well, we don't want that. We want that positive angle all the way around. So in this case, we'd have to add 360 to that, okay? So your final answer here would be 291.8 degrees. Now, I'm not going to go into why we have to add those. That goes back a couple months ago, back when we did the trig and the inverse trig functions. But here's a screen real fast about kind of your cheat sheet for determining your actual final answer depending on what quadrant it's in. If you're in quadrant 1, whatever the calculator tells you is fine. Leave it alone. That's your final answer. If you're in quadrant 2 or quadrant 3, whatever you put in the calculator, you're going to add 180 to that calculator answer, and that's going to be your final answer. And then if you're in quadrant 4, like the one we just saw, you're going to add 360 to the calculator answer. Okay? So, and again, that just goes back to what the restrictions of the tangent function are for the inverse trig functions. And again, so find your vector, know what quadrant it's in, and then follow that along. And again, if you need to pause the video real fast or take a picture with your phone, to make sure and hold on to that for the problems later on. So that's magnitude and direction, right? So what if we don't have standard form? Sometimes we are giving you a vector that's just described by 2 points. That's not in the standard form or component form. So let's take an example here. So let's say vector A starts at 5, -3 and ends at -2, 1. So there's my 2 points. And that would be my vector. You know, that's still a vector because it still has an endpoint and a start point. But in order to do anything with it, in order to find magnitude or direction or whatever else we're going to do later on, we need to have that in component form. So how do you do that? Well, it's as easy as this. You take the endpoint minus the start point. Super important to know that order. Okay, so end minus start, you just subtract the x's, subtract the y's, and you got it. Okay, so in this case, -2 minus 5, 1 minus the -3. Watch the signs as always. You end up with -7, 4. So instead of being there in standard form, now my vector is there. It's the exact same length, exact same orientation, but now it's in standard form, so I can find the magnitude and direction if I wanted to. Okay, let's do that one more time with a different vector. So let's say my vector B is -1, -6, and ends at 3, -4. So go and pause the video real fast and see if you can find that vector in standard form. And we'll keep on going in just a couple seconds. So again, it's always going to be endpoint minus the start point, x minus y. I'm sorry, the x's and then y's. I apologize. So we got 3 minus -1, 4 minus -6 is 4, 2. And again, standard position would be right there, 4, 2. Okay, so let's do a sample problem that kind of covers everything about those basics of vectors. So let's say I've got a vector b starting at 5, 7 and ending at -2, 2. And I want to find component form, magnitude, and direction. Okay, so first things first, find that standard form. So again, end minus start, so -2 minus 5, 2 minus 7 ends up being -7, -5. That's my vector. To find magnitude, remember that's my notation. I just do the Pythagorean theorem. So -7 squared, -5 squared, that's 49 and 25. Add those together. Root 74, and again, if you want to put in a calculator and get 8.6, I don't care one way or the other, is fine. And then finally, for the direction angle theta, again, inverse tangent y over x. Pop that in the calculator, mind the order. The calculator tells you it's 35.5, but remember, this is in quadrant 3, both of them negative, so it's at quadrant 3. And remember from that previous screen, we need to add 180 to that answer, so my final answer would be 215.5 degrees. Let's do one more example, and again, I'm going to ask you to pause the video on this one to do this one on your own. So there's another starting point, end point. Find that vector in standard form and find the magnitude and direction. Okay, so hopefully you got that. So the standard form n minus start would end up being -2 minus -6, 10 minus 1, which is 4, 9. Now we can find the magnitude by the Pythagorean theorem, which is root 97 or 9.85, either way. And then you find your direction angle, inverse tangent. Calculator tells you about 66.03, but notice my vector is in quadrant 1, so I'm good. So that's your final answer. Okay, so the last thing we're going to do is we're going to do some operations. Okay, because they're pretty straightforward and it's very kind of common sense as we get into these. So let's talk about adding, subtracting vectors. So what if we have these two vectors a and b? If I want to add those together, what do you think? I mean, just out of what does common sense tell you we're going to do here? Well, you probably said we're just going to add the x's and add the y's, and you would be correct. As always, watch the signs. So we're going to do 3 plus -4, add the x's, -5 plus -1, add the y's, ends up being -1, -6. Okay, and that's it. That's all there is to it. I do want to show you what it would look like graphically also, because it's a good way to kind of check your work. You have some graph paper handy. So if I graph the first vector, so that's my 3, -5. And then if I graph my second vector, -4, -1, is right there. But look what happens. What if I, instead of having that second vector b, what if I move it down and start it at the end point of a? Instead of, you still go the same direction. So I'm still going to go 4 left and 1 down. So now it's going to be there. Well, look what happens. If I draw a vector from the origin down to that spot, look where I'm at. I'm at -1, -6, which is what my answer is. Okay, so again, I'm not going to have to do that on an assignment per se, but it's a good way to kind of check your work. So let's take this one kind of step further. What if I want to also multiply a vector by something? We call this scalar multiplication. If we multiply something just by a number out front. So I left a the same. I changed my b vector just to make it a little easier to graph at the end, so I'm going to run out of room. So let's do this. Let's do 2a minus 3 times b. Well, what do you think we got to do first here? In this case, that 2 and the 3 are what we call scalars. It's just a coefficient. So all we got to do is we're going to distribute those coefficients through the vector, and then we're going to combine just like we did before. Okay, so we'll have 2 times a, -3 times b. So 2 times a, again, distribute, 6, -10. and then distribute that -3. Remember, this is if you distribute by the negative, that's going to change to a plus. So that's going to become 3, 3 inside, multiplied by the negative on both of them. Combine them up, and you have 6 plus 3, and then you have -10 plus 3, which would give you 9, -7. Okay, and that would be your final answer. You're done. Okay. Now again, what would that look like graphically, just to show you? So there's A again. If I do 2 times A, is that. If I do vector B, -1, 1, that's that little tiny green bit. But if I multiply by -3, it becomes 3, 3, which is there. But just like I did last time, if I move that down to the end point of 2A, I have that, and look where it ends. If I draw that vector there, it's at 9, -7, which is exactly what I got right here. Okay? So that's your operations with a scalar also. So again, it's pretty common sense. Distribute if you have a scalar, and then just combine the x's and combine the y's, watching your signs all along. Okay? Let's do one on your own. So again, here is your vectors and an n. Pause the video one last time and find what 4m plus 1/2 n would be. And we'll go through the answer in just 1 second. Okay, so again, we're going to distribute and then combine. So 4 times m and 1/2 n. Distribute the 4 and the 1/2, you get -16, -20, plus 4, -2. Combine the x's, combine the y's, and you end up with -12, -22. Not bothering graphing this one because it would go way off the graph anyway. So, but that said, that would be your final answer. Okay. So to recap this whole video, I know there's a lot of information, but it's pretty straightforward, I think. So remember, component form, the little pointy brackets, also called standard form. Magnitude with those double bars, Pythagorean theorem. Watch your signs, always going to be positive. Direction angle, tan inverse of y over x. Again, mind what quadrant you're in, and always make sure you're in degrees, whatever calculator that you're using. And remember that screen we had too, as far as adding 180 or 360 if you have to, depending on what quadrant we're in. If you're given only 2 points of a vector, make sure you can find the component form by doing end minus start. Again, subtract, watch your signs. And then finally, if you're adding or subtracting or scalar multiples, remember you're going to distribute that scalar first, and then you'll combine your x's, combine your y's, and watch signs, as we always say. Okay? So I hope you found this video helpful. There will be an assignment posted on Classroom over all this stuff. Won't be too long though, I promise. If you have any questions, please feel free to log into the Meet Room or drop me an email, or if you have a different teacher, you can email them also, for sure. Hope you're well. I miss you guys. Look forward to seeing those of you that are juniors. Look forward to seeing you guys when we do return back to campus in August. Those of you that are seniors, I will certainly see you at the virtual graduation, and hopefully at the real graduation, hopefully maybe like in July or whenever they reschedule that. In the meantime, you guys stay safe, be well, and keep studying.